that has fixed it. That's what I get for watching my own stream. Yeah, anyway, as I was saying, it's been a long time coming. I've wanted to do this project for a long time. I started several years back working on this. Then as things go, life got in the way a little bit, and I figured it's time to start back up. I have always been a fan of the Baldur's Gate franchise, specifically the Infinity Engine games. When I found out that GemRB exists, which if you're unfamiliar, GemRB is an open source project that allows you to run Baldur's Gate games on any system, basically. The system, it's fully re-implemented in an open source fashion, and similar to OpenMW for Morrowind. There's been a lot of open source re-implementations of like old N64 games and NES games. Super Mario 64 comes to mind. There's a full open source re-implementation of that. Yeah, I love these open source re-implementations. It allows for games to live on in ways that the creators could have never hoped for. And I think that's important. I think preserving things is, especially things that have had an impact on I mean, I want to say the world, but it's not necessarily accurate, but they've certainly had an impact in their little niche areas of the world. All the way to Baldur's Gate 3 and many other CRPGs that exist have that same look and feel as the Infinity Engine captured. And the Infinity Engine, arguably, it wasn't the first, but it arguably perfected it. And then it was just limited by the graphics capabilities at its time. However, as great as GemRB is, it has some limitations. Specifically, it is lacking multiplayer support. So, to that end, I have decided that I'm going to reverse engineer that protocol. I work professionally in cybersecurity, hacking, various different devices. My company right now, we specifically focus on medical devices. So, hacking is something I do as my day job. This will give me a chance to do it for fun again. I mean, I enjoy what I do in my day job, but it's being asked of me to do it. Nobody's asking me to do this, which I think makes it a little bit special. I have created some tools to help me with this process. The code here is specifically the sub-process that decrypts the packet, or, decodes the packets. The packets are unencrypted insofar as I can tell. And I've got the two tools here. There's IE-MITM, which is the standard Infinity Engine man-in-the-middler. And then this IE packet decoder is the tool you just saw. The reason I have them separated is largely because it's helpful for... I don't want to have to restart the whole game process every time I discover what a new packet is doing. If anyone has watched the Live Overflows series on the Pony Island Adventure CTF, you'll be familiar with this, because he did a very similar thing, except that he was using Python. And Python has a function called reload, which allows you to do this in real time. Go does not. I'm not a fan of Python, especially for working with data structures. I don't like strut.pack and strut.unpack. So to this end, I've decided to work on it using Go, and I've created a standard program which handles the initial man-in-the-middle relay part of the connection. But I've created a second program that will connect to that, and if that program is connected, packets will get rerouted to the decoder application before they're forwarded on, so that I'll have an opportunity to display them, decode them, and I can rebuild that code at will and not cause anything to happen to the main connection. So, not a perfect solution. It does have some limitations right now, but all things considered, I thought it was it was an elegant enough solution for me to proceed with it. So, just getting started here. My Windows key is my leader key on my system, so I got to be careful not to do that. Get started. We run this program. I always build it first, just in case I've made changes. And 3 flags there provided are the IP address of this system, specifically the virtual machine bridge IP address of this system. followed by the server and the client machine's IP addresses. So the screen on the left-hand side, it will be the server. Screen on the right-hand side will be the client. So the IPs are there listed in that same order. I believe that's correct. Yeah, we'll figure it out if it's not. So I launch that. I come over here, and I also launch this one. So with both of these running, I should, or no firewall issues, be able to start the game connection. Ah, yes. So now we're getting some dplay packets. The whole system runs on dplay. Dplay is an interesting thing. It was built in the time before multiplayer games was strictly meant IP-TCP. It supported modem connections. It supported serial bus connections. So all of this pre-negotiation is done over dplay. Once we get into the actual game, that's where the Infinity Engine packets kind of start to take over. So now you can see I'm just getting these packets, and it doesn't show anything about what they are. But if I come over here, we can see the packets that have been coming through. Mind you, those are just the unknown packets. Right now, there are constantly ping packets, such as those 18-byte packets. They're not necessarily pings. Protocol's interesting. It doesn't make a lot of sense to me yet, but it will. It seems like there's frame number 0. There's like 2. I should mention, too, I'm also doing this with the help of another project. If anyone knows anything about the Infinity Engines, the Icewind Dale 2 source code was lost, which is why there was no Icewind Dale 2 Enhanced Edition. They were unable to do that because they didn't have access to the source code anymore. Somebody has started doing a reverse engineering of Icewind Dale 2 to do a complete, like, one-to-one re-implementation of the source code. You know, GemRB, it strives to be, like, the Infinity Engine alternative that can play all the games, whereas this strives to strictly be Icewind Dale 2. That said, they've done a good job of reverse engineering several of the things that are helpful here. It's like C network, or actually no, it's just C network, I believe. If we look in here, you can see we've got some little tidbits of information that may prove very useful, and actually already have. For example, there is a CRC checksum that happens in here. So I was able to pull this directly out of Icewind Dale 2, and I was hoping that it would work for Baldur's Gate 1, and sure enough, it does. So the same CRC function that they're using in Baldur's Gate, or in Icewind Dale 2, they used in Baldur's Gate 1. So hopefully that means other things will be translatable into the source code, or into the, translatable back to Baldur's Gate. So, that said, those ping packets that we were talking about, seems like they all just operate off of these frames. So, frame send here, it basically says if the frame kind does not equal 0, then it creates a new frame using some of the statics that it has defined. But if it is 0, then it uses the original buffer that I guess never gets popped off. That buffer ends up staying at the top of that stack. I'll have to look into it more, but yeah, if we look back over here at our thing, well, actually, never mind. Well, it's a good example of how we can rebuild the program. Let me show the pings that are actually coming through. So we show these. I'll just do this. So now the pings will actually come through. If I rebuild it, it'd probably be helpful to have new lines at the ends of each of those. That means I'll just want to say, I'll just do that. Just out of laziness. So, rebuild and launch it. So we can see frame kind is always 1 on these ping packets, which lines up with what we were seeing here. So, I guess there, yeah, if the frame does not equal 0, then we just build it from scratch. I guess I had that backwards. In any case, yeah, frame kind gets set as that first byte, which the P data field here, where it starts at subset 0, that begins after the player from and player 2. So starting with frame kind and moving on, that's where those packets are coming from. Interesting. I guess I have work people who are still awake and sending messages. Oh. Interesting. I guess I'll tell them. Tell Felix, anyway. Alright, yeah, we'll see if he wants to come and watch me hack. So, in any case, yeah, this buffer starts at 0 there. I guess I should be watching my Twitch chat. Sorry if anyone's actually been messaging me. Oh, well, that seems to be spam. Best viewers on. There we go. Mod view. That's what we want to have anyway. I'm quite new to this part of Twitch here, so more options. Okay, in any case, got that open. So, yeah, frame kind is 1. That's at data subset 0. Then we have the frame number, which follows that, which we can see is, is right now is 0. That changes as I interact with things. And then we have the frame expected, which I suspect is a way of keeping track of where things are. And actually, when frame expected is there, I think frame expected is 1 minus the actual frame that's expected. Actually, yeah, no, the code reflects that. So frame expected minus 1 is right there. So that's good to know. I had noticed that earlier. So frame expected is 9. So watch, I'll toggle these on and off. We get that packet. And so now frame expected is A on that one. But you can see the frame number that went through. Well, so if I do this again and frame expected is showing A, we'll see a packet come through. And that packet, if we look right there at the frame number that comes through when it comes through, that frame will be B. And there it is. Frame B came through, even though it said frame expected was A, and now our frame expected has been updated to B. So yeah, that matches exactly what the code is showing. So my CRC function does work, at least in the test bed, but I tried it on here inside the code to do just like a basic check to see if my CRCs match. And I think I got something wrong with that because the maybe having to do with Indianness, it may be having to do with not copying the buffer. I think that's what happened. Anyway, frame expected, if the frame expected doesn't match the next one, I imagine it treats it as a ping or maybe just drops the packet on the floor. Not all of this code is done, so it will be difficult to say exactly. So okay. I guess I should probably put this over on this page as well. That will be more helpful for actually seeing messages as they come in real time. we go. Much better. I also need to figure out how to get patchy going in here. Maybe if I use this authorization key. There we go. Now I can say... Good. Let's see how much I have. Alright, Patchy is up and running. If anyone doesn't know, Patchy is my side project. Patchy basically is a Twitch bot that I've been developing for a while now, along with Allerin. If you're not following Allerin, he's another streamer friend of mine. Yeah, he's got some basic features, and I may as well kill two birds here with one stone and test him out while I'm streaming this. Hope to add a lot more features in the future, but yeah, what we got is pretty solid for now. There, now we've got that up and running. And I've got the code to bring him offline when the time comes. I don't have the event sub set up for my account, because my account is specifically for testing purposes, so I tend to not do things the right way. Because, you know, that's how that works. Okay, so, anyway, let's stop seeing these pings. Those are kind of stupid, and I don't want to deal with those right now. We'll kill that bit of code. But we will keep seeing any other packets that I don't know what they are, which is most of them. So, let's see what happens as I toggle these on and off. As I'm toggling these on and off, I need to figure out what's going on with my Python program. That crashed too. I've got a Python program running in the background here that's watching my current window and changing, talking on OBS WebSockets to whatever screen needs to show up. I'll have to debug that as time goes on. So yeah, I got like 3 different code projects. Nothing major here that I'm dealing with, trying to fight with on stream. But okay, so this packet is definitely the toggle my character selection. Looks like, or toggle my readiness, because you have to click both of these to be ready. There's also this packet that I can send where I can give control of another character to another player. So, looks like the first difference I'm seeing is 43, 42, 43, 42 for the toggles, and 46 for the give control. That one looks to be a little bit longer. I imagine that there's the player ID in there somewhere. So, what's the player ID? 1F6A. See if we can find that in there. And also the Indianness of this may not be correct. So, I'm just looking for 1Fs or 6As in there, but not necessarily in that order. You know, there's a better way to do this. Copy this whole packet, and then I can say, over here, 1F. There's only one F in there. Yeah, so apparently that player ID is not used for the thing. Yeah. So there must be a different mechanism for identifying the player. I guess I could look at the player chats. Those would help, potentially. So, but we could look at these other packets. So let's go ahead and do that. Take all of these guys. over here. Okay, so we've got all these packets. That 4A4D, that we can see in the actual Icewind Dale source code, right up at the top. Yeah, it's this JM constant. I'm not sure what that is. It seems to get inserted whenever they're making... So there's add to incoming queue that gets called in, check the incoming queue, and it's mem copying some data there, including that JM data. I think it also happens on when it makes a duplicate of a packet. This looks to be a lot to do with the incoming queue stuff. And there's also whenever the shutdown packet comes through. So that may just be something that's on most packets. It may be some kind of an identifier. Not sure about that yet either. We shall see. There's also MG and JB, which we can see get used in other places too. So the MG gets used there versus the JM gets used there. I suspect we'll see some of those as we start playing the game. In any case, yeah, so those are... That's what that part of the packet is. So I'm suspecting that's some type of packet identifier. You know, why there would be just 3 different types of packets, I'm not sure. Maybe JM is the mnemonic, I'm not sure what it would be. But it seems to come through on every player interaction. See if it comes through whenever we talk. 4A4D as well, when you send a message. 4A4D. And these, I mean, it's fairly clear that there's the raw ASCII in here of the actual message that's getting sent. And that includes the player name section of it, where it says, you know, this is also a player name. I think we can show that better using Wireshark. Go ahead and fire that up. So if we go on BIBR0, we can see all of those packets. I'll give you a nice long packet so we can find it. There it is, 79. Yeah. So there's the JM that we see at the beginning of the actual data stream. And then it looks like there's just, what, 5 bytes after the JM, followed by the actual thing. And I know that that is going to be the packet length of that specific part of the packet. So yeah, there's 37 and 36 here. So 36 is going to be the length of the rest of the message. 37 is going to be the length of the rest of the message, including that length. So, and then we just have 00, 01, 00. It does not get us a lot to work with for saying, like, hi, I'm a chat message. You know, that's odd to me that that's all there would be there. Let me try this packet again and see what it looks like inside of Wireshark. So, there's that 96 long packet. Okay, so it has the JM as expected, 000100, followed by 48, which looks about right for that packet length. Yeah, I need to get better at doing base 16 math in my head, but so 4 times 16 plus 8, so 72, and the whole thing is 96. Yeah, so minus 8 there, and minus another. So yeah, now that checks out. So Not sure how it would know what kind of a packet it is. If it's, I mean, unless it's like, oh yeah, it has to start with a non-printable character, and then this is the actual packet identifier in that case. But if it starts with a printable character, then it's... Yeah, let's see what this one looks like. There's that 91 packet. Yeah, we can be done with that. So, if anyone has ideas, I don't know if anyone's actually watching this yet, if I'm just recording this for posterity and getting things moving. If anyone has ideas, feel free to jump in. I am happy to hear some things. So 43 followed by FF. So it may be that if a packet doesn't get followed up with FF, it's going to be a chat message. You know what? I think we can try this. I need to figure out my checksums first, though. I'm going to make sure that my checksum function is working. So let's do that. Let's focus on fixing that checksum function, and then I can do some packet injection. Of course, I will have to... That's one of the shortcomings of my program as it stands. I'll have to do that inside of this tool, which is the... Well, sorry, not this tool. I'll have to do it inside of this guy, which means the whole game will shut down for a moment. I don't have it built in where I can send stuff from the other program to this one, and it performs some action. I suppose I could do that. What I'll probably do is just do a time not sleeping here for now and add this code later that does that. Okay. Also, I'm convinced there's some sort of, there's some exploits available in this. I haven't dug in, but max string length is there. It's set at 200. So we go over here and we can see things like IP address, modem address, phone number. Lots of things use max string length, including, I think, the session name, which is what the game gets started out with. Yeah, session name and session password. But then we can see that later on, those things get strn copied by, or mem set by the size of the thing. So, yeah, so that could be a problem if we were able to give it some more data, potentially. Session password. Yeah, we mem set it by the size. But I suppose the size would just be that for right now, because it wouldn't have anything in it. But we do call session password.getLength and could do a strn copy into that. So I imagine that I imagine it's just the UI that's stopping us from doing an overflow there. Because sure, they use an strn copy, but like, what's stopping me from having a longer password is probably just the UI that's stopping me, so the packet probably doesn't have such a limitation on it. It might, but, it gives me pause whenever I see this, so... In any case, let us go ahead and try doing the CRC check as packets come through. So, as the packet comes in... oh, sorry, we're on the wrong program. So we calculate the CRC based off of the buffer starting after the first 8 bytes, and the full buffer after that. So, we'll do that. Probably need to do a byte copy. So, not positive what we have to do that. I guess there's copy. It's a built-in function. Okay, that's easy enough. So I can say over here, let's open up our CRC code. And inside this function, I believe what we need to do P data. Actually, sorry. Right. And then we can say copy data into P data. There we go. So that should fix it. Because I think what I was doing before is I was overriding these values and it broke things. So let's find out. That's what was going on. I'll say CRT32, that versus that. There we go. Now we're actually making use of it. Oh yeah, the function doesn't live here anymore. It's in CRC dot. So we'll say and then we'll say from there it's just CRC checker dot calculate. There we go. And I don't think it's buff. It's actually called packet dot data. And then packet dot size minus 8. And then okay, so that should work now. Go over to this. Fill that and rebuild and go. Oh, undefined. Hey, more doubloons. I guess I should roll. Did get dubs. Hot should be, yep, hot does increase as expected. Okay. So, where's my in that was undefined? 927. Ah. Yeah, so we get 3F AA 86D4. So it's as if we're 1 byte off. It should start with 0, 1. Otherwise, the rest of it's correct. So I'm not sure what I did wrong there. Yeah, back over here. So this is the test case that I used for it. I put in a packet. And I calculated its CRC. I was calculating correctly. So it's more than likely I was getting the data into the packet. Oh. This could be part of it. No, okay. Yeah, I was setting that. This was a ping. This one was not. The initialization happens there. And this is where we actually do the data stuff. I know I'm close. Just have to figure out what this is. I guess I should. In this message. Okay. So, I guess here's a packet. You know what, I'll have it print out the whole packet, that's what I'll do. And I'll try running that through the thing manually and see if I can get it to reproduce what I've got going on here. Yeah, I'll make a separate program that does that. So, we'll do this. And we will now print out the whole thing instead of just the post header part of the packet. So I'll have it do this. Alright, so now we've got the whole packet. Hit. Ground player. We can say now. I guess I could have just gone over to Wireshark and got the packet as well. It'll work just the same. I'll do that for the next one I need. So we'll go ahead and create another program here. Call it CRC check. We'll say, let's replace every 2 bytes. So, there we go. Let's say that's what it's doing with the byte array. This is just how we're generating it over here. So we'll just call it P data in here as well. So we'll replace any two characters with subset 00 equals. Oh yeah, I need to capture the data. And then we'll record this. I'm sure there's another way to do this in Vim to change all of these to iterative numbers, but in this case I don't know how to do it, so I will just do it this way. QQ. And we'll start off and say down R1, down R2, down R3. In that. Okay. So now we can say there is 96, and so I'll say 9 at Q. Oh, 91, even better. That really worked out. So for this one, I'm just going to remove all of these zeros. And then R2 down. Say again 9 at Q. QQR3 down. 9 at Q. QR4 down. Q. 9 at Q. And there's surely an easier way to do this in Vim, but I don't do this specific task often. Maybe going through this, I'll have to teach myself how to do it better, but in any case, as I said, this works for now. 9 at Q. Oops. QQR6 down Q. 9 at Q. QQR7 down Q. 9 at Q. QQR8 down Q. 9 at Q. QQR9 down. I think that was actually it. No? What happened? Oh, okay. That makes sense. Or does it? My bad. I have to do it all again. Because I started at 20 rather than 10. So QQ R6 down Q9 at Q. QQ R7 down Q9 at Q. QQ R8 down Q9 at Q. And 90. Cool. Okay. So all that data is primed and ready. So that's that packet that we just got there. We know what the CRC should be versus what we actually showed for it. So that's good. Now with that in place, I can say func main. Oh, hello, gooey milk. Gross. So, we'll go ahead and go all the way to the bottom. Start building this out. So, hopefully we can figure out what this CRC function's actually supposed to do. Well, no, I've already got that figured out. We're just going to figure out why it's not doing what it's supposed to. Why we've got 1A47 CFC versus A47 CFC F8. Like, it's an off by one thing, so I think we can figure it out, though. Once we have that figured out, then we can start playing around with some packet injection and start really figuring out how does this thing identify the difference between chat messages and not. So, here's our CRC calculation. We'll do that. So we can say var p data is a, say it's 100 byte. Actually less than that. Actually 90. So I could just say it's 91. So one extra there. So now we can say there's the CRC checker. And then we have the whole packet there. We need actually the packet -8. So I'll leave that in here. Say 8 to 90. Say 90 minus 8. Leave that in there. And then I can say, just printf. Cool. Okay, so now I can go build that. Protocol RE. And we go to IEMITM, CMD, CRC. Go build. Oh, yeah, sorry. Oh, hey, Gooey Milk. Yeah, hello, good of you checking in. Well, yeah, have a good night. See you later. Hopefully you can, come back and see the progress when there's actually real progress being made. So, either way, appreciate you stopping by. Okay, so what do I want to try now? That's right, we're here. There we go. That was the problem there. Undefined packet. Yeah, that's right. The packet.data doesn't exist, it's just called pdata. That doesn't look right. 80, 39, 80, 38, 95, 39. Yes, that is not at all right. So that's even wrong from what I got. Do that. That's probably part of it. Actually 91 bytes long. Yeah, that's correct. 1A47CFC is what I'm supposed to be seeing. It's dropping off the 1. So that bit shift is happening one too many times. That's happening one too many times. So let me just do this. Just for giggles. Let's see what happens when we do that. No. That ain't no good at all. Let me add one to it. Didn't like that. I'm iterating it every time, I think. Oh, okay. I didn't even read the actual error, so we are going out of range when we do that. All right. So we will see. Why would I be off by 1? That's what I don't get. Well, I've tried doing. That's why not, you know? Weird, because we were doing it right over there. So you know what? Let's try it over there and make sure that we're doing it right. The other piece of code. And then it'll tell me if it's a problem in this or that. Oh, it could be that I'm not zeroing that thing out like I should. That's right, I'm not doing that. There is part of it that needs to be zeroed out. Well, no, okay, that happens in the CRC function now. Or should be, anyway. Right, 6, 7, 8, and 9 should automatically get zeroed out. I have to believe it'd be wildly off if those bytes were... This is a good opportunity to learn more about CRCs and how they're working behind the scenes. I've usually just have generated them, not written my own thing to do them. Do is we'll take off 1, 2, 3, 4, 5, 6, 7, 8. Take off those 8. It starts with 0, 0, 0, 0. Okay. Unfortunately, that also means I gotta redo all my numberings. It's 82 size there. DW size. Do that. Okay, so now we'll run this one. Let's see. I think that's worse. All that work. 1A47 CFC. Yeah, that's definitely worse. So I keep breaking stuff whenever I'm doing this manually. Not sure what's... How would it all be off by one? That's probably my path of least resistance. It's actually understanding the code rather than just spray and praying this. A little bit too hackery. Oh. I realize my green screen struggles whenever I lean forward. Interesting. Guess that's encouragement for better posture. But okay, so... Okay, the loop starts out the same way. Convert the data. And that's identical as well. Okay. So for each one of those, it takes the CRC of that, takes the DWCRC and masks it with FF. And orders it ID itself. Sorry, I'm doing bitwise stuff in my head, trying to picture it. May not be the best course of action. Maybe better to actually draw this out, but sometimes the answers can come to me this way. Let me bit shift. Oh, 8. Okay, so that's why just changing this size wasn't going to fix it. Haha, that might be it. Now that I think about it, seems like it could be. Okay, no. It starts with that one. Yeah, that makes sense. So 1, 2, 3, 4. And that's our server ID, and that's our client ID, and then that's where our packet actually starts. So we want to start there through the end. That might be the problem, though. So it is actually size 91, size 90. Strange that doesn't seem to think it's any different. Definitely should be. Range. There's another one. Again, that one's just missing a 1 at the beginning. Dropping 0, 1 at the beginning and dropping the last 2 from the packet. Seems like that's the case every time. Let's see if that's ever not the case. This one maybe. 0, 1, 3, 8, 9, 7, 1. Nope, okay. That wants us to drop the last byte and add 0, 1 to the beginning. Seems to be always the case. I could hardcode that in there. See if it ever just doesn't work. I mean, this is a hacking stream. That's pretty hacky if you ask me, so. Could say something like, So I just do that. That'll drop the last byte off. Why not? We're getting dirty in this stream. Too dirty for Twitch. Well, let's make it. Oh, yeah, sorry. Should be 16. So do that just a second. Packet was it? 1A47 CFC. A47 CFC. Okay. We'll use this. Mark this as a dirty hack. So now, if we go and we rebuild this. Oh. We probably want to remove a little debugging bit there. There we go. Yep, they're the same, they're the same, they're the same, they're the same. I mean, if they're the same, then they're the same. So... Alright. Still don't know why it's working in one place and not the other, but that'll give me a clue for later. Because that's the operation that we're missing. How we get that operation in the normal thing is still a little bit of a mystery to me. Apparently it's there in the dummy code, because it worked. But either way, we are now able to calculate valid CRCs. Means I can theoretically send packets of my own. And the working theory was that the packets that don't follow up with an FF immediately after the JM 000100. Oh, and then the packet size. After that, if it's FF, then it's some sort of a system packet, because all of those appear to be FF. So that's probably what defines this as, like, hello, I'm a system packet, and then I am system packet 4D53, which is probably select a person. Yep, 4D53. One of them slightly longer. The unselect is slightly shorter. Because the select is slightly longer. So let's test that theory by changing this and saying that. And so we see we still get FF, and we get 4D53. So, okay, so that is not defining, unless it's like saying, hello, I'm a action on a player. Maybe it's specific to which player it is. Hard to say. Oh yeah, I'm curious now what this does, though. Over in this one. Okay. We got a different packet at first. That's a relatively short one by comparison. Okay, do we have our... Okay, so that may be saying, like, update the entire game's state. That might be part of what's going on with that packet. And so that's the one who's just... Because I was doing everything on the server thing. So doing it on the client seems to yield different results. So maybe we can... Okay, so we do it over there. And then the server sends us another one of those big update game packets. They both have JMs in them. And then, so yeah, that might be a packet ID, because this one has 00, 01, 00, and then what? 08? That one's new. And then 46, that one's also new. Oh, wait, no, okay, 08's the size. Then there's FF. And then we've got 4D72 and 4D53. So 4D72 may be the client saying, hey, I've enabled or disabled my player from being ready. And the 4D53 packet is saying update the entire game session. So that's kind of like, because the server, I imagine, has to propagate this information out to all the other players. And so that's probably what that is, because it's a relatively large packet each time. So yeah, that's kind of what I'm working with now. So if the packet gets followed up with FF, then it's going to be some sort of an action packet. Otherwise, if it's a printable character, then it's going to be a chat message. That's my working theory at the moment now. And I think that's solid. So, oh yeah, let's check our checksums. Checksums are holding up except for this guy. This guy, checksum did not hold up. And this one too. Interesting. Huh. Okay. So my checksum thing is not holding up long term. Not on the... Okay, that's why. It's not holding up on the client side. So it could be the way I'm parsing the CRC out. Of the header. That could well be part of it. Not sure. Either way, it temporarily worked, so... It got me a little bit further in this process. I can't validate this yet. I'll probably have to write that code. I don't want to write that code on stream, because that's going to be a little bit boring to write. I like to keep deciphering what packets are. So, I guess I should start making notes about things that I've discovered. Oh. Let's get some concrete stuff here. So, we'll send this message. There it is. Okay, so we'll copy that data. Say copy printable text. And then our printable text actually comes into play right here. Yep. Okay. So we know what that is. We know what that is. And we know there's our JM. We know what these two are. So we can say what happens if our string is longer than 255 characters? Oh, it probably can't be. It's probably going to be maxed out at 200. Let's find out. There's 26. Actually, I'm just going to drop off the Z to make things easier to count. 25, 25. Okay, so there is 100 characters. We should be able to send that one to go to Wireshark. We're going to send that one. And that could be part of the reason for that character limit. 147 characters. Uh-huh. Okay, and copy and paste doesn't work there. I just need to figure out how long my name is, so... I got 5, 6, 7, 8, 9, 10... Wait, so that's 5, plus 8's 13, 14, 15, 16, 17, 18, 19, 20, followed by 2 spaces, 1 and 22. So we've got 22 characters already. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, that's as long as it'll let me type. So we've got in here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 120 characters is the max the GUI will let me type in here. 120 characters plus another 22 characters. It's there. So it's 142. Let's see. 142 in hex. That should be 8E in Wireshark once I hit send on this message. I think I see. Oh, did it compress it? It might have compressed it, because I did see something to do with compression in there. So that's good to know, though. Compression can kick in at a certain point. Let's see if I can decompress it. I think it's zlib compression is what I saw in the Icewind Dale source code. If I can decompress it and find that flag, that'll be super helpful, so I don't just keep banging my head against the wall saying, what is this? There's the JM. 10000. Then we say 2F. And that's... Let's see if it actually... Yeah. So there's uncompressed message function. Here we go. If P data special message flag is 255. Oh, well, there we go. There's our FF we were looking for earlier. Otherwise, this is what we do. And we use Z uncompress, looks like. Okay. Well, that is going to be huge. So, P data special message flag. Let's see where that is. I'm assuming it's special rather than speculative. But it could be. So... apparently that's a 0. Which is odd. Let's see. Okay, so there's our server ID, our client ID. There's the packet expected frame 2A to E. Okay, well, let's find out. Hey, the balloons. No. So, by the way, those lights, eyes lighting up, that'll probably eventually be some sort of a hype button to use Twitch vernacular. Anytime I find something, I'll have his eyes light up. Just a fun little feature there that I could add in. So let's see what calls. And how it calls it. It sends P data. We fetch the message. If it's not compressed, how do we check to see the bit if it's compressed? Okay, well that's not going to help us. Somehow B compress gets set. According to this disassembly, though, it's never set. Ah, it gets set inside here. It's passed by reference. Node P data 5. So hey, here we go. Here's our compress function. That's helpful. Let's see where that function is. Right, it's C util compress. That's probably also where the uncompressed one is. So. Yep, it's just using zlib. So yep, let's just compress that zlib. Leave in go. Yep, that's correct. do. This is definitely a hacker move. But let's say copy. Nope, let's do it. Copy the C string. How does that work? Using bin walk to see it. And yeah, hey, there's our zlib compressed data. Ah, okay. So it's just pure zlib data, and it's at offset 28 in total. So we know there's 8 there, there's 16 there. So then there's 24. 5, 6, 7, 28. So just starting right there after the JM packet, it begins with compressed data. But how do we know that it's compressed, though? I guess it tells us up here at offset 5, so there's 8, and 1, 0, 1, 2, 3, 4, 5. I guess that is what tells us if it's compressed or not. Let's look at another one that we send. Don't we have one here? So, 8. $16, 1, 2, 3, 4, 5. Why is it 0F? That don't make no sense. So 0, 1, 2, 3, 4, 5. Okay. So yeah, the 5th packet, or 5th row after the dplay stuff, indicates whether or not it's compressed. Got it. So, nice. This would be a... Yeah, we figured it out. So, and roll. Okay. So now we know that that is the compressed flag. So, let's go ahead and add that into our headers here. We're actually making progress tonight. That is wonderful. I need to add that into this bit of code here. So let's see. So on that really long message, and we know it was encrypted. And okay, so right before the checksum. Aha, and that's where our that's where our issue with the checksum has been coming into play too. We've been accidentally, so our checksum function was actually correct. We've just been occasionally reading. So we'll say compressed byte. We were accidentally reading that byte as part of our checksum. That totally makes sense. Why sometimes that was working and sometimes it wasn't. And now, in this packet output that we do here, we'll also add in, just before the CRC, that, and then just before the CRC, we'll say compressed. There we go. And back over here, say go build, and the IE packet decoder. So that one is showing as compressed, and our CRCs are back to being valid. Yeah. Okay. That makes a whole lot more sense. So yeah, we just solved two issues there. So those packets are compressed. Let's see if we can decompress them. I think the decompression portion happens the 28th byte. What happened there? So new reader, IO reader. Okay. Yep, so we were getting a lot of compressed packets. That's clear now. Once we decompress this packet, I think we'll have a much better understanding as to what's going on here. Oh, I realized you never saw any of that bin walk stuff that I did. Whoops. My bad. There we go. Good stuff on the CRC side. Good stuff on the IE packet side. And now we're showing the compression. Now we will take data after the compression, which we do this so that you can actually see that. So we have this file in here, a bin walk on VG tests, and we can see that at offset 28 of that file, offset 28, which is right here, our compressed data actually starts. No, compressed data starts here. And it's using best compression. I think that will be important to know. We're using our constants inside of this. New writer level. New reader level probably as well. Oh, no, okay, new writer level is the only one we'll need that. So, we do need to make a note then. We'll go ahead and make it inside the actual... go. We'll need to know that for later for sure. And then the data is set up in here at 28 byte offset. So it starts with 78 there. It actually starts right there. Yeah, because there's at 1C. Okay, I was reading it as 28 and hex. Yeah, that's my bad. So, we've got our server player ID, our player ID, and then another 8, 16, 24 bytes off from that. Right? 8, 16, yeah, another 20 bytes off from that is our actual compressed data offset. And so there's our compression flag. Right, yeah, there's our compression flag. And there's our checksum. And there's our JM 000100, followed by the length of the packet, probably. And then something else. And then we begin our compressed data. So that's not full length of 2F. Well, okay. 2F minus 4 would be 2B. Yeah. D, D, E, F. Yep. So that is the full length of our packet. And then it follows up with a... I don't know what that is. Okay. So I can do some detection on, as the packets start with JM after the checksum. And we can start treating those in a certain way. So, say... packet.data minus the frame size, or the header size. And what would be minus the length of the header, which I have here, I believe. Let's see. Let's try this. Okay, so let's see what happens when we do that. Unsafe.size of. I don't think I've had to use unsafe in a real program before. I mean, operating system maybe, but... That's interesting. Why doesn't it show anything? I know it's that size, so I'll just do this for now. Okay. Alright. Yep, we got JM there. There we go. Start using this. Okay, so that way we don't have to use unsafe, which apparently is not working anyway. We'll just manually update that as we go along. So, okay, so we got the two-letter ident. We can say if it's equal to JM, actually, it's probably not unknown. Unhandled. Okay, well, that's quite enough of that. I'm trying to keep my stream out any of that nonsense. I can avoid it. One of the problems I have with trying to pick music online, though. There we go. Unhandled two-letter ident. And, yeah. But if the two-letter ident is JM, then we can see there's JM, and there's 3 bytes. So we'll go ahead and make a packet type for a JM packet. I got a whole bunch of stuff. This is stuff I put in here from years back because I was not sure about any of this. So this will probably all get blown away. I'll leave it here for my own reference, but... Alright. JM packet. I don't know what JM packets are. They come with an IE header. And then they'll have 2 bytes here. JM. And then they'll have 3 more bytes. And then what comes after that? There's the unknown 1, unknown 2, and unknown 3. Right after the JM. I'm going to send just a chat message on both sides. And so there's the JM. We've got unknown 1, unknown 2, and unknown 3. And then we have a full packet size, which I think is true of all of these. 46. And this one is compressed. And then we have a 4-byte thing that happens before the compression, I believe, in that one. 1, 2, 3, 4. And I believe that's where the actual compressed data begins. Not positive about that, though. Yes, unknown byte 1, unknown byte 2, unknown byte 3. And then packet length is going to be that byte. So once we know it's a JM packet, what we'll do, instead of just reading it into the IE header, we'll do the same thing here. Okay, let's call this JM header. Read that into JM header. And then now do this. And then after the JM packet header, and say we know what that is. It's going to be JM. We'll do it this way. And then 1, 2, and 3. There we go. And then packet length. Okay. Nice. Ooh. Probably do want to actually make some new lines there. Might be just a little helpful. Well, two, three, 4, 5, 6. There we go. Yep. Good. So now we're up to the encrypted data, I believe. Not 1,000% sure about that. Getting a lot of dubs on my rolls tonight. We'll send an extra long message. That one was compressed. No way I've listened to 1,000 different tracks. I know we've got something on repeat here. Alright, so that data. Yep, so 4 bytes off from there. That's where the compression begins. not know what those 4 bytes are. Yep, as expected. And it starts with the full length of the file. Yep. Or full length of the text. Okay. So, there's another 4 bytes on there. Probably in that header. So... all that. Add those 4 bytes there. So 1, 2, 3, 4. And it's 0, 0, 0, 0. Okay. So, yep. Let's see what Binwalk thinks about this. Interesting. It's 3 bytes away from being the compressed data versus the other one was right on top of it. So what is different? Send this big long message again and see what happens. What does a zlib compression header look like? Okay. So it starts with any one of these. Okay. So, good. I can just scan for the magic header afterwards, just like this is doing. And then I'll say, okay. And say, okay, packet header, followed by data. can say. And then I can say this. Actually, I'm going to do it everywhere. We're just going to say JM header. And I can say JM compress.data. So, for So, that looks promising, and then what other options do I have? So it all starts with 78, and then 01, 5E, 9C, or DA. Zero 1, 5E, 9C, DA. B equals, so these are all of the header types that zlib can use. So we'll say the compressed offset is -1, and then we'll say, okay, basically we look through here, we look for 78 because they all start with 78. That's the case, it looks promising. And then if looks promising is true, which I don't even have to, I'm an idiot, and it's fine, it's not a big deal, but just looks nicer if I do it right. And then I say if any one of those, I'm going to say break and say compressed offset equals I. Actually, it's I minus 1. And then do this. Compressed offset is greater than -1. And we'll print that. Otherwise, say that. And it'll be, instead of packet.data, all that. I'll say there we go. So where's this thing? Compressed offset's not 0. We want to show the stuff that came out before that. And so we'll just print each hex byte there. And that would be what? JM compressed dot data sub I. And got dash there. Okay, so that won't look too terrible. It's starting to get a little ugly. But that's alright. That's what hacking's all about. Things being ugly, but they solve the problem. Okay. Oh, binary read failed. Invalid type JM packet compressed. But it is a valid type. Might have to declare the byte size for that read to work. Yeah, that would be my guess. So let's just say way bigger than it could ever be. Yeah, that should be bigger than it should ever need to be. Cannot find compressed data in packet. Oh no. Oh. Yeah, that would probably do it. Yeah. Okay, it's printing all that data. Let's fix that. I don't want to print all of it. What is it? JM compress dot. What is it? It's gonna be length of it somewhere. Yeah, minus compressed offset. I could probably have to convert this to an int. Okay, let's see if that does any better for us. Yeah, looks much better. All right, so we have officially got to the point where we have our compressed data. Now let's see what it is. That should be easy enough. Just compress zlib. There's a little sample code that should do it for me. Let's see. Oh, let's decompress. Yeah, with queso. My wife would have a fit at how they're pronouncing queso. But she also says avocate and all sorts of other Mexican words. Very Mexican-esque. And technically speaking, avocate is Mexican, not Spanish. I can dive into that. I'm also... I tell people that, reverse engineering protocols like this is very much like deciphering unknown languages. So, if this is just another language, it's just figuring out how to figure out, figuring out how to figure out what they mean, what the different things mean, and, try to, look for patterns and ascribe meaning to them. So, I have a gift with languages and with, I like to think with this stuff. It's been a long time since I've got to reverse engineer protocol. I think last time I was doing protocol RE was with, I think the MySpace IM protocol. I worked on that for Pigeon. So, yeah, I'm sure there's somebody else who would have looked at this and immediately saw 7.8 DA and was like, oh, that's C11. So, there's certainly things that you will miss no matter how much you've done this sort of thing. But, yeah. In any case, I enjoy it. Whether I'm particularly skilled or not. So we have the compressed data. We go here, and then we can say decompress. It takes data from and to. It will be this string right here. Basically this whole thing. Just spread out a little different. So we'll do that. Data from and data to. And it'll return a byte array and an error. Otherwise, we'll do encode hex to string, and we'll do it on the returned value, which is decompressed. Aha. So finally, we shall see what this data looks like. Right. Aha, okay. We finally got to our first little issue with that field. That I can just use copy. Yeah. Oh, my bytes will say. Then we can say copy. Okay. Moment of truth. Slice out of bounds. That has a capacity of 0. Interesting. So you know what I'll do? I'll just fix the underlying problem rather than try and do it the wrong way. We'll say that. And I know this is going to error, but it's going to tell me what the error is. So I always... So, invalid type in. So, that's going to be... binary.read. So, the invalid type. Ah, that's how I'll fix it. Okay, that's an easier solution anyway. I can say this. We'll read the header first. And rather than trying to read it into that, equals IE dot okay, so we just copy those two things in there. And we have a null array there to start with. But then when we get to this, we can just say what? Down here we do the same thing. Packet.data. DM compressed header size. Thanks, Patchy. Appreciate that. Yeah, Storm blew those rolls right off. I blame the Storm too. Appreciate you, Patchy, always looking out for me. Okay. So, we need to... What was I doing? Oh yeah, we need to copy that data before we can do this. So, and that's it there. Okay, now. There we go. Take all of that, and I'll just say copy. There we go. Okay, so now we have a copy of that data in our byte array there. And then everything else should just work. All the way including the compression stuff. Alright, moment of truth again. Could not find compression data in the packet. Okay, so that means the data doesn't get copied correctly. So maybe I need to build that thing first. I'm gonna save there. Extra data is a byte array. And then see if that changes anything. Right. Oh, and that could also be part of it. I don't think it's part of it, but it could be. Data. Just out of curiosity. Yeah, it's empty. Why is that? What I could do, could use a pinned. There we go. Okay. Now we get our data, our compressed data stream. Yeah! That is what we like to see. Woo! So, close that out because I don't want to see that every time. There's that data stream. What does this one look like? Oh. It's just not compressed. And it's just 1 or 0. Okay. Which, I guess that makes sense. Either means that we're ready or we're not. I bet if we had another character, it would have to be all of them before we're actually declared ready. So, and each time the game session gets updated, I'm guessing all of those are just individual bits that mean different things, like permissions and whatnot. Yeah, let's actually see. So, let's give player that. There's going to be one difference, and I see it right there. There's that bit. Okay. Yeah, we are now ready to start deciphering permission sets. That is wonderful. And I'm guessing each one of those is a different slot for each different player, which makes sense. There's my message. So, $20, 3A. So, unknown, length 28. And then, since it's uncompressed, we're just getting the uncompressed. Alright. Yep, we are definitely making some progress. This is great news. So tonight we have figured out what was wrong with our header, discovered there's a compression flag there. We have managed to then also, through that same process, fix the bug that was, seemingly occurring with our CRC checks. And yeah, we got it coded all the way to the point where we can now officially decrypt, I guess decompress the data that is being sent there. So each one of those is clearly just bits representing different flags. Still not sure what defines an actual message versus information. It might be the 00C7 that's showing up there. Those get sent in each one of those versus it does not get sent with that one. But I don't know how the game would know what I'm saying whenever I do that versus when I send a message. So there's still some stuff to be figured out here. But nonetheless, we are definitely making some progress. Just because I'm going to actually join the game and see what happens. Let's clear out the ciphering. We'll say done, and we'll watch the game load. Oh, and we got a panic, which is hilarious. But the data before the compression was unique. So now we are getting lots of data. That is probably NPC data, if I had to guess. Most of it's uncompressed, so that's interesting. The compression only occurs, at least predominantly occurs, before you get in the game. I wonder what happens if we go in somewhere quieter. That's got to be animation data then. Like, basically nobody was walking around inside there. It's gonna be a problem if I can't move my window. I think maybe that was an Icewind Dale only thing. Interesting. Keep getting repeats of the same looking set of packets while paused. And so far, nothing has been compressed. Well, then, are these JM packets? Yeah, they're all JMs, too. And all have the exact same unknown values. 0, 1, 0.
Oh, crap.
Interesting.
Saturday, sure. My God, what have I done?
So, I think that's about where we're going to have to call it for the time being. I think we'll be okay. Yeah. All in all, I think it was a good start. Definitely a good stream. We will proceed with more of this maybe tomorrow night. I'll leave the video up, and if anyone wants to catch up, there's plenty of catching up to be had. So, well, with that, everyone, I appreciate you all stopping by, and we will see you maybe tomorrow, but definitely by next week at the absolute latest. So, have a good night, everyone. We will see you on the next one.